In this lesson, we're going to be talking about performing operations on complex numbers, and we will be using those to solve quadratic functions that have complex solutions. So before we do that, I want you to think about this equation. It says x squared equals -1. Think about what value of x, if you square it, would give us -1. Well, if you substituted in 1, well, 1 squared gives you a +1, so that wouldn't work. If you substitute in -1 and you square that, well, that also gives you a +1. So what we find is that there are no real numbers that we can substitute in for x that when we square it would give us a -1. So mathematicians have created an imaginary unit called I. So I is equal to the square root of -1. So here is how we're going to use that to solve problems. The square root of -5. We're going to write that as the square root of -1 times 5. And then remember, we can take the square root of each of those. The square root of -1 then, by definition, is I. And then that would be times the square root of 5. And then the standard form, we would write it as the square root of 5i. We put the I at the end. So here's another problem. So the square root of a -16. Well, think of the -16 as -1 times 16. And the square root of -1 is an I. And the square root of 16 is 4. So that answer is 4i. The next problem says, how do you write the square root of -18 by using the imaginary unit I? Well, first of all, this is like the square root of -1 times 18. The square root of -1 is I, so you put an I at the end. And then the square root of 18, that has a perfect square factor in it. So we would write that as 9 times 2, because the square root of 9 is 3. So remember, we separate those out. And the square root of 9 is 3. So that would be how we would write that. Here's another one, square root of -12. So again, if there's a negative, let's put an I at the end, because that would be the square root of -1. And then we want the factors of 12 that have a perfect square, so 4 times 3. So the square root of 4 is 2. And we still have the square root of 3 underneath the radical. And there we go, 2 square root of 3i. Square root of a -25, well, the square root of a negative is an I. The square root of 25 is 5. Square root of -7, we have an I. And the square root of 7 is just the square root of 7. We can't simplify that any further. Complex numbers have a real part and an imaginary part. Now, in the set of complex numbers, we can have real numbers, which would be like a 10, for example, plus 0i. There's no imaginary part. We can also have an imaginary numbers included here. So this would be a plus bi. So like 7 plus 2i. That would be an imaginary number. Or a pure imaginary number, there would be no real part. So if you just have 6i, that would be a pure imaginary number. And when we write complex numbers, we typically write the real part first and the imaginary part second. That would be our standard form. And imaginary numbers are interesting because they are used in various places in real life in higher sciences. And one place would be in electricity. So this is just an example here that shows where imaginary numbers are used. We have Li right in here. So there's an imaginary number right here. Now, let's look at the sums and differences of complex numbers. Basically, when you add complex numbers or subtract them, it's just like adding like terms. You're combining like terms with variables. So 7 minus 2i plus -3 plus I. What we do is we add the real part. So 7 plus a -3 would be 4. And then we add the imaginary part. So -2i plus 1i would be a -1i. So it's just like adding like terms. Here we're subtracting them. Now the only thing that you have to remember here is you're subtracting all of this, so you need to distribute the negative through. So 1 minus 3 is a -2, so add the real part. And then 5i plus 2i is 7i. Let's just do a couple of those. Here, we're adding them. So add the real part, 4 plus the minus 4, they cancel. And minus 3 plus 3i, that's 0. So that answer is 0. Here's another subtracting problem. So 5 minus 3i, and then minus a minus is a plus 2, and minus a positive would be a minus 4i. So 5 plus 2 is 7, and minus 3i minus 4i would be negative 7i. Some rules that we have with imaginary numbers is no imaginary numbers can be in a denominator ever. And when we work with them, we want to simplify and deal with the imaginary numbers first. Now, some other properties here, I is equal to the square root of negative 1, we said. Now just note, if you squared both of these, this would cancel this basically. So I squared would equal a negative 1. So that's the other thing that we need to know. If I is equal to the square root of negative 1, I squared equals negative 1. So whenever you see I squared, we substitute in negative 1. So looking at this problem, first of all, it says simplify and deal with the imaginary numbers first. Well, right here we have the square root of negative 1. So we're going to go in and substitute in an I right here. And here we have the square root of a negative. So the square root of a negative is an I, and the square root of 25 is 5. So this is 5i. From here, we're just subtracting. So 6 minus I minus a minus is plus 4 minus 5i. 6 plus 4 is 10. Minus 1 minus 5 is minus 6i. And that's your answer. So keep in mind, I is equal to the square root of negative 1. Whenever we see the square root of negative 1, we can put an I in. And I squared equals negative 1. So whenever we see I squared, we substitute in negative 1. And we're definitely going to use this when we start multiplying complex numbers. So here we have 7i times 3i. So multiply the real times the real, which would be 21. And I times I is I squared. But remember, we said I squared equals negative 1. So it would be 21 times a negative 1, which is negative 21. Here we have to distribute because we're taking 4i times this complex number, so that would be negative 24i plus 4i squared. So negative 24i plus 4, and I squared is a negative 1, so substitute that in. Now, recall standard form puts the real number first, so I'm going to write negative 4 first, and then negative 24i next. And let's go ahead and go to the next screen here. Here we have a binomial times a binomial, a complex number times a full complex number. So we're going to double distribute or FOIL. So first would be 2 times 4 is 8. The outside ones would be 2 times 5i. That would be 10i. The inside values would be minus 12i, and the last would be negative 15i squared. So now we'll go through and combine like terms. So 10 minus 12, that would be, let me erase that, that'd be a negative. Negative 2i, and then you have minus 15, and I squared is a negative 1. So we need to just write that is a positive 15 then. So now we'll combine our real numbers. 8 plus 15 is 23 minus 2i. All right, one more like that. So we'll multiply. Negative 36 we would have. And 7 times 9 is 63i. And then the inner times the inner would be a positive 8i. And then we have negative 14i squared. So we'll combine our like terms. So we have negative 36 plus 71i. And then this is like a negative 1 right here. So you have negative 14, or negative 14 times negative 1 is a positive 14. And so that would give us a negative 22 plus 71i. All right, and then remember too, we said that we can't have imaginary numbers in the denominator. So here we have an imaginary number in the denominator. So what we can do is multiply by I over I. Remember, anything over itself, like 5 over 5 or 2 over 2 is equal to 1. So I over I is the same as 1. And so you can multiply by 1 without changing the value. So what this does for us is in the numerator we would have 4I minus I squared. In the denominator we would have 6I squared. So I squared equals a negative 1, so we'll substitute that. And now we have 4I plus 1 over negative 6. So we no longer then have the I in the denominator. And then to simplify this just a little further, 4I plus 1, each of those are getting divided by negative 6. So let's write 4I over negative 6 plus 1 over negative 6. And we can reduce those fractions. 4/6 is the same as 2/3, and that's a negative. And then we have plus a minus, so minus 1/6. And standard form, lastly, just would switch the order there. We'd put the real number first, and then the imaginary number last. So that's how we do a problem like that. Now, when we have an expression in the denominator, we can't just multiply by I, because if you distribute the I through, then this would be 4I squared, but then you would just have an I here, so you would never be able to get rid of the I by doing just that. So we do what's called multiplying by the conjugate of the denominator. The conjugate is the first and the last term, but you switch the sign. So 1 and 4I, but the sign switches. So if this is a minus, this is a plus. And you have to do the same thing in the numerator there, because this is equal to 1. So now what we're going to do is we'll have to FOIL the top and FOIL the denominator. So FOIL the numerator, FOIL the denominator. So we have 2 plus 8I plus 3I plus 12I squared. And in the denominator we have 1, and that would be plus 4I minus 4I minus 16I squared. So that would be 2 plus 8I and 3I is 11I. And then this would be 12 times a minus 1, so this is minus 12. And here in the denominator now, look at this, 4I minus 4I, that cancels. And this is a negative 1 right here. So that gives us 1. Negative 16 times negative 1 is a positive 16. So then we have 2 and a minus 12 is a negative 10 plus 11I. And that is all over 17. Or you could write that as negative 10 over 17 plus 11 over 17I. So these are equivalent. All right, let's go ahead and do this one right here. We'll do one more for practice. So again, we have an expression in the denominator. So we are going to multiply by the conjugate. So that's 8 plus 7I. The conjugate would be 8 minus 7I over 8 minus 7I. So in the numerator, we FOIL. So we have 64 minus 56I minus 56I plus 49I squared. In the denominator, we'd have 64 minus 56I plus 56I minus 49I squared. So let's just write this as I squared is a negative 1, so this would be a negative 49. This I squared is a negative 1, so this would become a positive 49 right here. So in the numerator, we have 64 minus 49, that would be 15. And then minus 56 would be minus 112I. And then in the denominator, the I terms cancel. And we have 64 plus 49, which is 113. And so we could write it this way as our answer, or write 15 over 113 minus 112 over 113i. All right, now let's go back to solving quadratic equations and see how we're going to be using complex numbers. So first we have just an x squared. So let's solve by taking square roots. And so to do that, we will want to isolate the variable term. So we have 2x squared equals negative 48. And then we'll divide both sides by 2. So x squared equals negative 24. And to get x squared, to solve for x squared, to solve for x I should say, we take the square root of both sides. So x will equal plus or minus, oh, we have a negative underneath, so that's going to become an I. And that would be the square root of 24, but we have a perfect square factor of 4 there. So we have to write that as 4 times 6. So x is equal to plus or minus, the square root of 4 is a 2, and then you have the root 6 still, and then you have the I. So this would be your answer. Let's go ahead and do one more. We'll add 8 here. So we have x squared equals negative 28. And we'll take the square root of both sides. So x equals plus or minus. We have a negative, so that will be an I. And the square root of 28, we have to think about perfect square factors. 4 goes into there 7 times. So we would have plus or minus, the square root of 4 is 2, and you have root 7, I. And let's do one where we're actually going to need to use a quadratic formula because we have an x squared term and an x squared term. So we write a, b, and c is 2 minus 3 and 7. So x equals negative b, so minus a minus 3, plus or minus the square root of b squared, so that's 9, minus 4, a times c would be 14, all over 2a, so 2 times 2 is 4. So that would be 3 plus or minus 9 plus, let me see, 9 minus 56 would be a negative 47 over 4. So that would be 3 plus or minus, and the square root of a negative is an I. So it would be root 47i. And the whole thing is divided by 4, which means we can also divide both terms by 4. And so that would be our solution to that quadratic equation. All right, let me know if you have questions with that. Thanks for watching.